Welcome to SAT Math question number 41 here on Wagner Academy. It says if exactly two of the three integers L, M, and N are odd, which of the following expressions must be even? This is an important word to consider here. It's got to be even, must be even. So if I can show just one counterexample for any of these expressions, I've proven that it doesn't have to be even. So let's try number one there, L, M divided by N. So I could pick whatever two of these that I wanted to be odd. If two of them are odd, one of them has to be even. And so I'm going to say that the even one, just for example's sake, is down here. And I'm going to say these are the two odd numbers. If I could come up with a counterexample, I will disprove that this has to be or must be the case there. So this is for one, I'm going to go with three pretty basic integers, 3, 4, and 5. Two of those, 3 and 5, are odd. And so if we had the even number down here, you could say 3 times 5 divided by 4. That would be 15 over 4. Is 15 over 4 an even number? No. It's 3.75, which I would say is neither odd nor even. So, expression 1, no, not working there. Expression 2, does this have to be and must it be even? So if you have two odd integers here and one even integer, let's check this out. So it's all multiplication. It doesn't really matter the order in which you multiply things. So I could say that this one's even and these two are odd, or these two are odd and this one's even. Doesn't make a difference. So I'm going to have, no matter what way I put it, I'll have an even times an odd because of the commutative property of multiplication. The order in which I multiply things doesn't make a difference. So I know that an odd number times an odd number, if you take any number times another odd number, you're still going to end up with another odd number. 3 times 9, 27. 3 times 5, 15. 5 times 25, 125. It doesn't make a difference. I'm not going to go and give you a proof of that, but you're still going to have an odd number each time. And if you take an even number times an odd number, you'll always end up with an even number. So 2 seems like it always works. It always has to work that way. Even times an odd, it's always going to be even, because an even number is going to have a factor of 2, and the factor of 2 when multiplied by an odd number will always wipe out the oddness of it, I guess you could say. And then number 3, let's see if this always has to be the case. So if you add L plus M and multiply that quantity times N, does it always have to be even? So you could have the even number on the outside here, or the even number inside the parentheses here. Those are your two options, basically. So we have two options here. Let's check both options. We have one option being the even on the outside. So if you added two odd numbers, odd plus odd, and multiplied it by an even number, an odd number plus an odd number would always give you an even number, and an even number times an even number will always give you an even number as well. So that's one option. That option works, but does the other option always work? If you had an odd number on the outside and an even number on the inside. So if you take an even number plus an odd number, integer, and multiply that by an odd number, do you always end up with even, or do you always end up with odd? So if we have an even plus an odd, there's going to be, from that odd number, there's going to be that one extra. You're not going to have a factor of 2 when I add those two in there. So you're going to have an odd, and then an odd times an odd, as we discussed before already, is going to be an odd number. So option 1 works, but option 2, that would be a counterexample just to prove that to you that it's not going to always work. I could use those same odd integers, 3 and 5 and 4 for my even integer, put the even integer on the inside with one of the odd integers. This is showing a counterexample for option 3 here. So 4 plus 3, that'd be 7, and 7 times 5 would be 35, showing that this does not always have to be true. It doesn't always have to be even if that's the expression you're using. So, looking through our choices here, only expression 2 worked. That's 2 only, our choice for The 41st question here on our SAT practice questions should be choice A.